Hey guys, this is CPM 2, Module 1, Lesson 5. This is subtracting integers, which is section 3.2. So, our first objective is to subtract integers. It says in section 2.1, Module 1, Lesson 3, we learn the opposite of integers. So, for example, the opposite of 3 is -3, and the opposite of -6 is 6. In this section, we will use opposites to subtract integers. So, to subtract integers, we rewrite the subtraction problem as an addition problem. So, right here in this first one, it says 10 minus 4. Okay, so we've done subtraction before. We know that 10 minus 4 is 6. Okay, but if we have more opposites, if that is switched, what we do is we change that. That's the exact same thing as 10 plus a -4. Because if you use this right here, that means the opposite of 4. So the opposite of 4 is that -4. So since both expressions simplify to 6, this means that they're the same thing. So when we subtract two numbers, the first thing we're going to do is keep the first number You are then going to change the subtraction sign to addition. I'm going to do, now I'm out of room, so now to plus. And then you are going to flip the sign of the second number. Okay, and I purposely kind of boxed those answers. We're going to refer to this as keep, change, flip. But what we mean by keep, change, flip is first keep the first number, then change the subtraction sign to addition, and then flip the sign of the second number. So if the second number is positive, we're flipping that sign to negative. If that second number is negative, we're flipping that sign to positive. So here in this very first one, this is another one that we should know, right? 8 minus 5, that's going to give us 3. But if I'm following these steps, you can see that when we change this to subtraction and then use our addition rules, that we get the same answer. So if I'm using my rules, we are keeping this first number. I am changing this subtraction sign to addition, and now I am changing my +5 to a -5. So if I use my rules for addition, which these are opposite, so we subtract and keep the sign of the bigger number, that makes this 3. Okay, let's try again with B. We've got -4. We're keeping it. We're changing the subtraction sign to addition and changing this +10 to a -10. So now use your addition signs. Now we have the same sign, so you add and keep the sign. So 4 plus 10 gives me 14, and keep that sign of a negative. Now with this one, you can do this one of two ways. If we use that keep, change, flip, that means I've got 6 is what we're keeping, change the subtraction to addition, and then changing this -5 to a +5. Or if you remember from our intro to integers lesson, negative turns into a giant plus, which is exactly what we have here, 6 plus 5. So either way you go about that, you do get 11. And so do one of the two options, keep the first number, so -11 comes down, change that subtraction to addition, and then your -7 turns into a +7. Or just take that double negative there and change that to a plus. Either way, -11 plus 7, we've got opposite signs, so subtract. So 11 minus 7 gives me 4. and then keep the sign of the bigger number. My bigger number is 11, so -4. All right. So example 2, translate the following phrase. Then we need to simplify it. So find the difference of -15 and -10. Difference here means subtract. So that means we've got -15 minus a -10. So use your rules. Keep the first number, -15. Change subtraction to addition. And then flip this sign, so this -10 becomes +10. So -15 plus 10, use your addition rules. We've got different signs, so we subtract. 15 minus 10 gives me 5. And keep the sign of the bigger number. The bigger number is 15, and it's negative, so that my answer is -5. On B, it says subtract 7 from -3. Okay, remember this key word from. When it says from 3, that's your starting point. So I've got -3, and from that 3, I'm subtracting 7. So that means -7. So keep the first number, -3. Change your minus to addition, and then take this +7 and change it to a -7. So now we have the same signs, so add and keep the sign. So 3 plus 7 is 10, and we're keeping that sign of negative. Objective B, we're adding and subtracting integers all in one problem. So notice on A, all of these here are minus, so that means I'm changing all of these. Because it says right here, if a problem involves adding and subtracting more than 2 integers, rewrite differences as sums and adds. You may add numbers in any order, but we will do it from left to right. So use your same rules. This 7 is your first one. This is what you're keeping. Now you're changing subtraction to addition, changing this +8 to a -8. And keep going down the line. You're now changing this addition sign, the subtraction sign to addition. We're changing this -5 to a +5, changing our minus here to a plus, and changing a +1 to a -1. Okay, so let me do that one more time. On this 7, that's the very first one, we're keeping it. That's the only keep. So then it's like change, flip, change, flip, change, flip. Okay? So this minus becomes a plus. Your +8 becomes -8. This minus here becomes plus. We're changing the sign of this -5 to a +5. Changing this minus to a plus, and that +1 becomes -1. So now I have nothing but addition here, so now simplify. So if I just start over here with the furthest one, 7 plus a -8, those are different signs, so add and keep the sign of the bigger number. So 8 minus 7 is 1, and 8 is bigger, so this is -1. Bring down everything else. So +5 plus a -1. Here, -1 plus 5, same thing. Different signs, add and keep the sign of the bigger. So 5 minus 1 is 4. 5 is bigger, so this will stay positive. So then bring down your plus a -1, and same thing, opposite signs, so subtract and keep the sign. So 4 minus 1 is 3. Keep the sign of the bigger number is 4, so it stays positive. So my final answer is 3. Now with B, notice that we have one addition and then 2 subtractions. So because this is already a addition problem, just keep it. So I'm going to rewrite 7 plus negative 12. This is my first keep right here. So now we need to change and flip, and then change and flip. So negative 12 was my keep. This minus turns into a plus. My positive 3 is a negative 3. Bring down that minus, turn it into a plus. We're flipping it or changing it. And then this negative 8 into a positive 8. So same thing. Start from left to right. So 12 plus negative 12, different signs, so subtract. 12 minus 7 gives me 5. Keep the sign of the bigger. 12 is bigger, so this is negative. Bring down everything else, so plus a negative 3 plus 8. So then here, for the first time in example 3, we have the same signs. Same signs means you add and keep the sign. So 5 plus 3 is 8, and keep that sign of a negative. And now we have 8, or negative 8 plus 8. These are opposites. Opposites are always 0. Objective C, evaluate an algebraic expression. To evaluate, remember this just means you need one single number answer. So plug in. X minus y. So here's my x minus my y. My x is negative 3. And my y is a 9. So we have a subtraction problem. So keep, change, flip. Keep the negative 3. Change the subtraction sign to an addition sign, and flip this second number. So that positive 9 becomes a negative 9. So now we have the same signs. So add and keep the sign. So 12 plus 9 is, 3 plus 9 is 12. And then keep that sign. They are both negative, so this is a negative 12. B, do the exact same thing. We've got 2a minus b. So I've got 2, this is where my a goes, minus, this is where my b goes. So a is 8. My b is negative 6. So order of operations, that's my please, excuse, my dear Aunt Sally. We have no parentheses, we have no exponents, but I do have something to multiply. So 2 times 8 is 16. Bring down everything else. So minus a negative 6. So now that it's a subtraction problem, keep, change, flip. Keep your 16. Change the subtraction to addition. And flip this sign of the second number. This negative 6 becomes a positive 6. So now 16 plus 6, that's just a nice old plain 22. And then last page, objective D, we are solving problems by adding integers. On example 5, it says the highest point in the United States is at the top of Mount McKinney, at a height of 20,320 feet above sea level. The lowest point is Death Valley, California, which is 282 feet below sea level. How much higher is Mount McKinney than Death Valley? So unlike our other word problems for adding integers, it was like we had this little diver right here, and he was going so far below the surface, and then he went so much more below. Because it was going down and then further down, you had to add those numbers together. But now with this type of problem, because we're talking about going up and then my other one is down because it's going in opposite directions, that's how you know you need to subtract. So we've got 2,032 minus, when you are below the sea level, that's a negative. So minus a negative 282. So change flip. Keep your first number, 20,320. Change your subtraction to addition, and then flip this sign. So because it's negative, now it's just going to become positive. So now we just need to add these numbers together. So we've got 20,320 plus 282. So 0 plus 2 is 2. 2 plus 8 is 10. Carry your 1. You've got 3 plus 2 is 5, plus the 1 we had to carry up here, so 6. And then 0 comes down, 20 comes down. So my answer is 20,602. And then we are in units of feet. So we need to put those feet on our answer. Example 6, the bar graph shows monthly average temperatures of Fairbanks, Alaska. Know that a negative temperature is illustrated by a bar below the horizontal line representing 0 degrees Fahrenheit. Use this graph to answer the following. So we need to find the difference. The difference means subtract. Find the difference in temperature between the months of November and December. So November is 3, December is -4. So that means since it's difference again, we've got 3 minus a -4. So keep your first number, 3. Change your subtraction to addition and flip this number so negative becomes positive. So now it's just 3 plus 4, so we get 7. And so 7 what? We are in degrees Fahrenheit. So the difference is 7 degrees Fahrenheit. B says find the difference in temperatures between the 2 months with the lowest temperatures. So my lowest temperatures is that -8 January and -4 December. And so again, difference means subtract. So that means we've got -8 minus a -4. So keep your first number, -8. Change your subtraction to addition. Flip your second number so it becomes a +4. So this time you've got opposite signs. So subtract and keep the sign of the bigger number. So 8 minus 4 is 4. My bigger number is 8 and it's negative, so negative. And so again, we are in degrees Fahrenheit. So this is -4 degrees Fahrenheit. Example 7 says the coldest temperature ever recorded in the U.S. was -80 degrees Fahrenheit in Alaska. No, thank you. The warmest temperature ever recorded was 134 degrees Fahrenheit in California. That's still a no, thank you. How many degrees warmer, how many degrees warmer is 134 degrees Fahrenheit than -80 degrees Fahrenheit? So again, because these are opposite, right? If you have like your little thermometer thing here, here's your 0 degrees Fahrenheit. You've got one that's way up here, and you've got one that's way down here. Because they're going in opposite directions, you've got to subtract. So we've got 134 minus a -80. Either take that double positive and change it to a giant plus sign, or keep your first number of 134, change your subtraction to addition and flip this sign so it becomes 80. So we've got 134 plus 80. 4 plus 0 is 4. 3 plus 8 is 11. Carry your 1. And then you've got 2 right there. So how many degrees warmer is 214, and we're still in degrees Fahrenheit in this problem, so 214 degrees Fahrenheit. And then your last problem, this should be example 8, so my bad there. Translate the phrase into an algebraic expression. Use x to represent a number. So this says the sum of -5 and a number. So the sum means to add. So it means we've got -5 plus a number. We're using x to represent that. So plus x. And then B, subtract a number from -20. Remember that from something, that's your starting point. So from -20 is where we start. And we're subtracting a number from it, and our number is still x. So minus x. All right, that's all I've got for this lesson. I'll see you next time when we start multiplying and dividing integers.